There's been a lot of cool stuff with open muscle. Let me just share on the screen. I've tried to document as much as I can, just pretty much did my best here to talk about what I was doing, how I was doing it. The difficulty that I find is that I'm just one person, right? I just believe that AI could easily discern finger movements from just what the muscles are doing in the forearm if I use pressure sensors. So it turns out that's a very trivial thing to do. Oh my goodness. It's so crazy how that works. You can see the little dips. Again, I have the files in the demo folder just because it's better. Now that the LASK is attached, you should see when the two lines go. The open muscle system is based off of the open muscle band and the LASK system. Let me just open up my box of goodies. So what I have in here is I have the LASK system that I developed because I wanted to create my own sensor system that measured the forearm muscles, but I needed a way to describe or to label the feature data. So the LASK system was my solution to do just that. It's a Wi-Fi client, and it sends UDP packets in JSON format to the host computer machine. And it's based off of this Diodario physical training device. What's also awesome about the LASK system is that you can use it for physical therapy or a pretty much an interesting human interface device. For someone that's undergoing physical therapy, it's good to get metrics, so it could be used as a standalone system for that. This could be used in a lot of assistive technologies. What's nice is that this isn't a zero force device, is that it's very easy to pick apart which fingers you're moving. It's going to very much contract the muscle. It's going to accentuate how much the muscle contracts and quantize your system. Because if you're doing AI learning for any type of sensor that has to do with the finger, this type of system is going to be really desirable for you to test the efficacy of your machine learning process. And so that's what I need to do. Since I was just one person, even though I go underneath the name Open Muscle, and it seems like it's a whole bunch of people, it's mostly just me, just to let you know. So the open muscle band, the most effective one, is the one that used the clevis pin system, and yeah, there's some extra wires. I increased the surface area of the clevis pin feet. This is what pretty much allows the muscle contraction or the muscle movement to be detected. If it's just the pin head or the clevis pin head, there's not enough surface area for the actual contraction to actuate these pistons. But I've gone away from that and onto a foam-based system. This foam-based system does the same thing. The signals are not as loud because it's just the surface area of these magnets. So by applying the feet, you actually get a comparable signal, and this is less expensive and less time consuming to make. And one of these wires, this is not supposed to be disconnected, so the wiring solution is probably the biggest thing that has to be adjusted for this open muscle band. The next version, I believe I'm going to try to tackle the wire harnessing problem. I do believe I have a couple of potential solutions for fixing the wiring. I also want to make this as least expensive as possible, but while still able to discern the 4 different finger moves. So the last system I'm going to improve to be less force and also hopefully include a thumb just for simplistic AI training. And this is great. This has been probably the easiest method for me to test my artificial neural networks on the different types of sensor systems. The LASK system really makes the problem a manageable problem because you're not using image-based gesture recognition. You get a really strong signal. Now, how could this be used if someone is missing one hand? You'd probably have to mirror, ask them to mirror, and then the training session would be a lot different. There's not going to be a one-to-one correlation with the open muscle band or whatever sensor band that you're using around the forearm. But just how crazy good this is at detecting finger movements, and 20 minutes of data is the sweet spot. I'm just sending the 12 sensor datas from open muscle with the 4 from the LASK, but I'm getting about a 50 millisecond delay from a detection of a finger. Since I don't really have these as Boolean values, whether the finger is moving or whether or not, I just have the actual output. So yeah, I wanted to give you an update on what was going on with open muscle. It's exciting. I think it's enough, again, since I'm only one person. I'm going to have some help on this. I don't know how far I can carry it by myself, but I will continue to do so. The team at Ultimate Robotics, they have the U-Myo sensor, which I'm using that in conjunction with my LASK system. And I think the marriage of their sensors, which are open source and open hardware, along with Open Muscle and the LASK system, which is open source and open hardware, is like a marriage made in heaven. So I submitted my projects to Hackaday under the assistive technologies, and that's what they're meant for. Open Muscle is meant to be a prosthetic sensor, and the LASK system is meant to be a prosthetic sensor labeling device for machine learning and also a physical rehabilitation device and potentially a human interface device. So that's in a nutshell. If you like my content, please like or subscribe. Let me know if you like what I'm doing, have any constructive criticism, and I'll leave off with let's see if we can make a positive difference in this world.